This video, we're going to talk about 7.3 Objective 1, where we define concepts related to best fit lines, regression, and prediction. So what is a best fit line and how is a best fit line useful? I've actually drawn a couple of these roughly in the last couple of videos. So a best fit line is a line that lies closer to the data points than any other possible line. It reduces the error in our and it's what we call a least squares regression line. How is a best line fit useful? Is useful to make predictions within the bounds of the data points. Now, do we usually get to make predictions within the bounds of the data points? Usually not. Usually we have to take this prediction and extrapolate it outside of the bounds of the data points, even though we're not really sure that it's a good model outside the bounds of the data points. But usually we're using these lines like this for what we call forecasting to make 5-year plans, 10-year plans, and so on. We take 5 years of data and project what's going to happen for the next 5 years, or 10 years of data and project what's going to happen for the next 10 years. And so while the textbook definition says you should only use these lines to make predictions within the bounds of the data points, in true application of statistics in the real world, we use these predictions to these lines to make predictions about things outside the data all the time. So what does the square of the correlation coefficient R squared tell us about the best fit line? So it tells us the proportion of variation that is accounted for by the best fit line. This is a weird wording, so I'm going to say it again differently in just a second. So for example, if R squared equals 0.9, then, or 90%, then 90% of the variability is accounted for by the best fit line, but 10% is not. So a better way for me to say that to you is if R squared is equal to 0.9, 90% of the change in Y can be explained by the change in X. That's a really good model. If I can say that changing my X variable explains 90% of my change in my Y variable, only 10% of the change in the Y variable is not explained by the change in the X variable and is due to other variables that are unaccounted for. I hope that makes sense, but that's how R squared helps us. The closer that R squared is to 1, the better our model is, because we would love it if 100% of our change in Y could be explained by our change in X. The closer that R squared is to 0, the worse our model is, because we wouldn't want 0% of the change in Y to be explained by the change in X. Then X and Y don't have anything to do with one another. All right, that's it for this video, and we'll come back next time and talk about 7.3 Objective 2. See you for the next video.